Welcome to today's talk. My name is Giacomin, and today we'll be talking about an absolutely fundamental tool we use in design, which is the prototype. We're going to talk about the concept of prototype, some of the uses of prototype, and some of the values of prototype. So what is a prototype? A prototype is usually some sort of early preliminary development. It's something that quite often is built to test, to check, to validate, maybe to discuss some of the characteristics with stakeholders. It's something incomplete, imperfect. It's a bit distant still from the final version, but it's really, really important for getting feedback, for checking things, testing, even things like safety testing. Why are prototypes so popular and used so much in design? Why all through history have we been building prototypes before attempting the definitive version? Well, the main reason actually is that it reduces the pressures on the human thought processes. It removes the need to remember and to recall and try to connect together so many different characteristics and so many different interactions. It gets out of here the ideas and onto a table so that we can actually turn it around, we can look at it, we can try things with it, we can show it to people, we can discuss it, we can work with it. So prototypes are absolutely fundamental to try to get the concepts away from the abstract and get them more into the concrete material such that everything becomes simpler in terms of thinking about the issues involved, thinking about the opportunities, thinking about the interactions. And the closer the prototype is to something of a more definitive nature, the more checks we can do, the more tests we can do, the more we can work with stakeholders, the more the concept can be fleshed out and validated. Thomas Edison it's sometimes claimed that he suggested that if a picture is worth 1,000 words, a prototype is worth 1,000 pictures. Tom Kelly of IDEO, the well-known design consultancy, has written on many times in his books and his articles, a picture is worth 1,000 words, but at IDEO we say that a good prototype is worth 1,000 pictures. And IDEO is an organization. On their website and on their materials, they frequently use the phrase, if a picture is worth 1,000 words, then a prototype is worth 1,000 meetings. All of these statements by these people are examples of the fact that the concrete, physical, practical manifestation in the form of a prototype can make everything so much easier, not just to check, but to discuss it with other people, to engage with the stakeholders. It reduces the number of meetings, it reduces the doubts, it reduces the uncertainties around the design process. So what kinds of prototypes are there? Now, there's many different names for prototypes, and different businesses and different organizations have different preferred semantics, words for these things. What we have here on this slide is just a little short sample, and it's just to give a feeling for the spectrum of prototypes that are possible. Many times you'll see in the design communities people discussing aesthetic or visual prototypes, and what they mean by that is something that expresses the sizes, the forms, the appearances to a sufficient degree to have gotten the concept out of the sketch, off the paper, and into something physical that we can turn around and look at, and we can judge at a distance. So it's about looking at it and using our visual perception to understand things about this concept, about this opportunity, and to make judgments about this particular concept. Proof of principle concepts, prototypes, quite often we'll build a prototype that only does maybe the one thing, or it only does a couple of things. It'll just be doing the key function or providing the key interaction that we consider to be absolutely critical and fundamental to the design. So much of what the artifact will do is not catered for, but the prototype is doing enough to check the big thing, which we thought was the main opportunity or the main aspect of the opportunity in the design. User experience prototypes, it's a term you'll see a lot in the UX community, user interaction community. Typically they express, or they're close enough in terms of appearance and close enough in terms of functions and capabilities to permit user research, to put the thing into focus groups, into workshops, to show to stakeholders, to engage with users and get comments and feedback and information that's beneficial to the design process. Working prototypes, usually when someone uses that term, they're referring to something that has most of its functions. So the Swiss Army knife has most of its blades and corkscrews and artifacts in the prototype, so we can check the different functions to see all the different ones if they're doing what we expected them to do. And in functional prototypes, this term in many settings is used by professionals to indicate a prototype which is very, very close to the definitive artifact. It probably does all the functions. It probably has the same shapes and colors and characteristics. Many of the materials are the same, but not everything is the same. Some of the materials may be different. There might be some minor variations in the sizes, and the way it was produced is different from the definitive industrial mass production technologies and techniques which are intended for the definitive artifact. So it's something pretty close, but it's not made using the industrial processes. Thus, there's some minor differences with respect to what a consumer or a user would be seeing on the shelf later. Prototyping, particularly digital devices these days, since everything tends to be digital and have quite a bit of automation and electronics involved. One of the distinctions you see a lot in the prototyping and design and engineering communities, particularly with digital prototypes, is the distinction between low fidelity and high fidelity prototyping. Low fidelity prototype is a term, it's a semantic used to refer to things which get the idea across. They could be sketches, they could be paper models, they could be plastic models. They're just simple things which have enough of the shape and the form and possibly the interactivity to give it a go and to show it to people and to get some basic information and do some basic tests to check if it does get received by the public in the manner we had hoped for. High fidelity prototyping instead is a term that's used to refer to something much closer to the definitive artifact, something which may have most of the functions and functionalities in there. If it was a digital product, it might have all the menus in place and you might be able to input data into the system and see something, if not the definitive response, some simulated response, which represents what the final artifact is it's planned to do. So there's this distinction between ways of checking the basic concepts and ways of checking the detail and the devil's in the details, checking some of the interactions and some of the capabilities, if they're smooth and frictionless, if they work out and get received by the users as well as we had hoped for. And a few years back, Rudd and his colleagues defined a table which lists the characteristics of these low fidelity prototypes and these high fidelity prototypes. And as you can see from the table, the low fidelity is something cheap and cheerful, it's something rapid, it's something that's quite helpful in initial or preliminary phases of a design project. It's about checking some basic assumptions and some basic theories if they're working in practice with the specific artifact you have in mind. High fidelity prototypes, as the table suggests, much more complex, much more expensive, may even be indistinguishable at times from the definitive artifact in terms of the user interface. So there's different levels of prototyping which tend to be deployed at different stages in the process, and they have different costs and different materials and different considerations. Now, in terms of the basic principles, whatever type of prototype we have in mind for whatever type of opportunity we're scoping out with our design project, there are some basic facts and principles and situations which tend to reoccur and reappear in most design projects. Some years back, Lim and his colleagues defined three fundamental principles, very simple, very basic, somewhat common sense, but it's worth noting and worth thinking about when you're setting out and deciding if this is the right point in the project to do a prototype or not, and what kind of prototype it might be. Anatomy of prototypes. Prototypes are filters of the design space. There's an infinity of opportunities out there for a designer. So many characteristics, so many materials, so many functions and possibilities, so many psychological reactions that could be stimulated. The prototype is a way of reducing that, narrowing it down to just a few key ones which we wish to check and proceed with. We've already eliminated a lot when we choose the prototype. Fundamental prototyping principle. The prototype is a physical concrete manifestation. It's only as good as its ability to answer our questions. So we have some doubts about whether 10 buttons is too much and 3 buttons is not enough on the control panel. The prototype is the way to check and eliminate these doubts. And the good prototype, or the useful prototype, is the one that helps to answer our questions, our design questions. That's all the prototype is intended for. And then the economic principle, which is unavoidable and nowadays is even more important than it's been in the past. And it basically states that the better or the more useful prototype is the one that answers the questions. It permits the interactions with the stakeholders. It permits the checks, the engineering checks or whatever is happening at that stage of the project in the least expensive, in the quickest, and most effective or efficient manner. So the economic principles suggest that prototypes, one of the main discriminants is how much is this going to cost us as part of the development process. Now, in terms of development process, materials, processes, prototypes, there's an infinity of variations out there. Different businesses have different preferences, different research establishments, different governments, different NGOs. Many differences occur simply because of preferences of the organizations in question. But of course, there will be some things that tend to repeat themselves and show up quite often. Commonalities in prototyping, there's quite a few in terms of materials and processes. You see a lot of prototypes made out of paper, if it's a low fidelity one, wood, plastic, software code, breadboards, simple circuits. There's a number of cheap and cheerful materials and tools which you see getting used over and over again to test out ideas. So there are some commonalities. Quite often it's due to cost, because the better prototype is the one that permits us to answer our question or questions with the lowest possible cost. In terms of materials and processes, it is important to note, however, that one of the complications and one of the sophistications of the prototyping activity is the fact that there is no simple right and wrong answer as to what is the best prototype to develop to answer that question. Design and prototyping are not scientific problems. It's not a right or wrong answer. It's a matter of efficient, effective, or less efficient and effective. And many studies have shown over the years that design questions and user interaction tests and even safety checks of engineering systems, quite often you can establish how good your design is operating and what deficiencies or defects it may have with a number of different prototypes of different type and different complexity. And quite often, it's been shown in proper research studies that quite often the simple, cheap and cheerful, even sometimes the paper prototype might be more than sufficient to identify some user interaction issues, to identify some safety critical issues, maybe even some engineering issues such as fatigue, life, and so forth. So quite often it's not possible to say definitively whether the low fidelity, the high fidelity is most indicated at that point in the project, and it's not possible to identify and say this material definitely will give me more guarantee during my validation process of this concept. Basically, many different types of prototypes can get you to the similar, if not the exact same answer. So this is a complicating factor and is worth considering. And sometimes it may suggest going for a simpler prototype, at least initially, given that we know that quite often that could be adequate to answer our design questions. And a final point is worth noting is the question of cost and the implications for the whole design process. A prototype, quite often, particularly large industrial engineering projects such as automobiles, aircraft, trains, buildings, train stations, large projects, prototypes will be expensive projects in their own right. The prototype could often be just as expensive, if not more expensive, than the definitive artifact itself. So it's worth considering that cost is a very important aspect of the prototyping process. Nevertheless, we have to balance the expenses that we're investing in producing the prototypes, using them in validation, testing, user interaction, what cost goes in to what benefit we get back, which of course is the fact we may identify important issues, possibly important deficiencies in the original concept. Things we had assumed may not be manifesting in actual practical use. So we will get back information which will help us to avoid these mistakes earlier in the process, thus saving significant amounts of time and money further down line in the development process later in the project design activity. So they have significant costs sometimes, but we must balance that against the cost savings which are likely to occur due to the fact that we identified some issues which are problematic at an earlier stage in the project, because we had a prototype which was good enough to help us to spot that before we invested much further in detailed engineering calculations, in manufacturing activities, in discussions with the people at the plant. So prototypes are expensive projects in their own activities. Many organizations have their own workshops and teams dedicated to prototyping, automotive concept prototyping, train prototyping, and so forth. And it's worth just considering what's the right balance between what we can save in terms of later expenses and what this specific prototype is costing us. The image in the slide provides a sense of how complex a prototype can be. This chassis prototype might be needed for safety testing, it might be needed for fatigue testing, it might be needed for all manners of mechanical checks. Just producing that will be quite expensive, but then we have to ask questions about where we'll be saving these resources later in the process. So thank you very much for your time and patience, and I look forward to speaking with you on the next occasion. Thank you very much. Goodbye.